Okay, in this class I want to look at just looking at three more theorems. There they are. You can pause the video and read through them. I'm just going to jump through into a couple of examples. So the first thing here, I'm just looking at theorem 7, and I want to list the angles in this first triangle from largest to smallest. Theorem 7 says the largest angle is opposite the longest side. Longest side is 9, so that's the largest angle, angle B. Theorem 7 says the smallest angle will be opposite the shortest side. The shortest side here is 4.24, so that's going to be my smallest angle, angle C. And then the remaining angle is going to be in between those two. Angle A is going to be smaller than B but bigger than C. Similarly, I want to list the sides from longest to shortest. The longest side, Theorem 7 says, is opposite the largest angle. Again, if I name the sides, opposite big C is little c, opposite big A is little a, opposite big B is little b. Well, side little c has to be the longest side since it's opposite the biggest angle. The smallest side will be opposite the shortest, the shortest side will be opposite the smallest angle, so little b opposite the smallest angle here. So that's going to be the smallest side, and then the remaining side is going to be in between those two things. Theorem 7, really straightforward. Longest side opposite the largest angle, shortest side opposite the smallest angle. Theorem 8 says two sides of any triangle are together greater than the third side. So can this triangle be constructed? Well, let's have a think about it. The shortest distance between A and B should be a straight line from A to B. Is it possible that going over to here to C, 5 units, and then all the way down here 8 units, which gives me a total of 13 units, is shorter than going from here to here? And the answer is no, of course. It can't be shorter to go from A to C and then to B. It would have to be shorter. So 14 should be shorter than 5 and 8, but it's not, so this cannot be constructed. So good practice is to go and actually try to construct that triangle. See if you can actually construct a triangle with those sides. You will find that it is impossible. Which of the following could be the three side lengths of a triangle? Could 3, 4, 5? Well, as long as two sides are together greater than the third side, then we're in business. 3 and 4 together are 7 greater than 5. 3 and 5 are 8 greater than 4. 4 and 5 together are 9 greater than 3, so that can be a triangle. 9 and 20 together make 29. That's not greater than 30. That cannot be a triangle. Try to construct it. You won't be able to. 8, 15, 8 and 15, 23, greater than 22. 8 and 22 together make 30, greater than 15. 15 and 22 together make 37, greater than 8. That can be constructed. That is a triangle. This one is not. There's no way you can construct that, but you could, using junior cert methods, construct either of those two. Theorem 9 is about parallelograms, and again you will know this already. In a parallelogram, opposite sides are equal and opposite angles are equal. So here's a parallelogram. How do I know it's a parallelogram? Because of the arrows saying this side is parallel to this, this is parallel to this. Theorem 9 says opposite sides are equal. So if this is 5 root 2, well, that's 5 root 2. If this is 6, well, this is 6. Also, opposite angles are equal. If this is 45, well, this is 45. Okay? What about the remaining two angles? Well, I would use something called the same as side interior angles theorem here, which says if a pair of parallel lines, here we have a parallel line passing through A and B, two lines, A to B and D to C, they're parallel. If they're being cut by a transversal, there's a transversal. Well, then they're pairs of alternate same side interior angles, that one and that one, must be supplementary. That means add to 180. That means that has to be 135. Consecutive angles in a parallelogram are supplementary. That's 135. And opposite angles in a parallelogram are equal. That has to be 135. Pretty straightforward. Theorem 7 and 8 and 9, probably the most obvious of all of the theorems in our course.